Okay, this is question 3 from December 2013. Gustav's height, it's called. It's statistics, probability, that kind of thing. So Gustav is considering or thinking about how tall he will become, how tall he will be when he's finished growing. He finds the information below on the internet, and then in the box you can calculate a region, expected region for a boy's expected final height in centimeters in the following way. Expected final height equals, and then there's that formula, father's height plus mother's height divided by 2 plus 6.5 plus or minus 8.5. So basically you can't predict with 100% certainty what height somebody is going to be, but you can predict it within a range, and that plus or minus gives you the range of values. So we'll see how that works in a minute. It says Gustav's father is 189 centimeters high and his mother is 167 centimeters, not high, tall. 167 centimeters tall. Then you have to show that Gustav, according to the information, can expect a final height between 176 and 193. So it's basically putting the information you're given into the formula and getting two answers. So the least his height can be is this expression here, the father's height plus the mother's height divided by 2 plus 6.5, and then you've got the plus or minus 8.5, so that will be the least if it's minus 8.5, and that gives the 176. Or the highest it can be is if you have 189 plus 167, the father plus the mother, divided by 2 plus 6.5, and then plus 8.5, and that gives you the 193. So the plus and the minus is giving you the upper and lower boundaries of what you could expect his height to be. And in this question, you'll get all of the marks for putting the numbers in the right place. You won't get any marks just for the answers because you've already been given the answers. Question 3.2. The curve on the next page, which is this one on the screen, shows the height distribution for Danish boys of different ages. When Gustav reached 15 years old, he was 174 centimeters tall. How tall will Gustav be when he reaches 18 if his height follows the curve which it was on when he was 15? So let's have a closer look at that. There's the curve, and his age and height at 15 are 15 obviously, and 174 centimeters. So if you follow those up and along, they meet on the blue curve. So that means that Gustav is quite tall for his age. He's at the 75% point, which means that 75% are shorter than him, and then 25% are taller than him. So throughout his life, he expects his growth to follow that blue curve. So if his growth follows the blue curve, then when he's 18, you can find his expected height by reading from the blue curve, and that comes to 183. So you expect his height to be 183 centimeters when he reaches 18. So setting that out neatly, well, hopefully the graph will be something on a separate answer sheet that you can just hand in, and then put these marks on to show how you're reading things off. And then on the main answer sheet, you can just say he will be, and write that you've read it off from somewhere, 183 centimeters. But obviously important, if you're handing in that graph as well, that it's neat and that it's easy to see what you've done and how you've obtained 183 centimeters from the graph. 3.3. What percentage of Danish boys at Gustav's age were taller than Gustav when he reached 15? Well, irrespective of his age, whether he's 15 or 18, his growth is following this blue curve, and that's the blue curve at the 75% point. But that doesn't mean that the answer to the question is 75%, because it means that 75% are less tall than him, and only the top 25% are more tall than him. So the percentage is 100 minus 75, only 25% are taller than him throughout his life, whether he's 15 or 18 or whatever. Okay, below is a set of observed values that shows how tall boys in Gustav's class were when they reached 15. The heights are given in centimeters. You have to find the median of the data set and explain what the median shows about the distribution of the boys' heights. Well, you might want to use my handy median finder and fill the values in and find it that way. But on the exam sheet, you've got to write something. So what I did when I did this question, I've written median, then I've written out all the values, and then sort of crossed them out from the ends until I'm left with the one in the middle, which is 177. If it's really a lot of values, you don't need to write them all down. You could just put ... between some of them. And that median of 177 means that half of the boys are 177 or more, half are 177 or less. And be careful to word it that way, because you could, in theory, have a lot of 177s in the middle, and some could be in the bottom half and some could be in the top half when you make the split. So you don't want to say something like half are above and half are below, because people who are 177 could end up in both halves. So word it like that: 177 or over, half of them, and then half of them 177 or under. 3.5. Compare the height distribution in Gustav's class and the height distribution for 15-year-old Danish boys generally with the help of quartile sets or box plot, or ideally both, because if you do a box plot, then you'll be using the quartiles. Explain with your own words what the comparison means. Okay, so this is what I did at the time. So I've split off the values to find that the median is 177, and then the quartiles are 173 and 183. So those are the people at the 25%, 50%, and 75% points. So you've got the highest and lowest values, the highest at the top and the lowest values shown by the little sticks at the end of the line. And then the box is showing the median in the middle, so about 177, and then the lower quartile, 173, the upper quartile, 183, and then you've got the same sort of information about the national distribution. So you've got the 25, 50, and 75% cutoff points from reading off the graph. You don't have highest and lowest values for the national distribution because it only sort of goes up to the top and bottom 2.5% or so. So it doesn't tell you who the tallest and shortest person is in the whole of Denmark. So for that reason, I've left off the little lines for the highest and lowest values. But you can see a general pattern that people in Gustav's class are a lot taller than the national average. So I've written the comparison shows that boys in Gustav's class are generally taller than boys in the rest of Denmark. Usually for a box plot, you want to say something about how spread out the numbers are as well. You want to talk about the position of the data and the spread of the data. I can't see much difference between the spread there. Perhaps I should have said that there's not much difference between the spread of the data, or perhaps it's best to leave it. So those are my final neat answers, nicely lined up. Question numbers, comment, calculations in brackets, equal signs, answers lined up at the decimal point, units lined up, double underlined answers, and down here are the marks available, 4, 4, 3, 4, 4.